Hi everyone. In the previous session, we have seen what are the static characteristics, and among the static characteristics, this error plays an important role because this error decides the behavior and the characteristics of instrument a lot. If error is less, then accuracy is more, and instrument performs very well. So that's why we need to much focus on the error itself. So what do you mean by error? Basically, error is nothing but it is the deviation of the measured value from the original value. That means the expected value. In the instruments, error is more commonly expressed as absolute error or percentage error. So error is more generally expressed as absolute error or percentage error. So as we have seen, the error is nothing but the difference between the expected value and the measured value. So here the absolute error is defined as yn minus xn. Here E is nothing but absolute error, Yn is nothing but expected value, and Xn stands for measured value. Now coming to the percentage error, because error may be expressed either as absolute error or percentage error. So coming to the percentage error is written as, percentage error is equal to absolute error divided by expected value into 100. So absolute error, what is absolute error? Absolute error is equal to this one, yn minus xn. So yn minus xn divided by expected value is nothing but yn. So divided by yn into 100. So percentage here refers to 100. It is another term, there is another term, accuracy. So in terms of accuracy also we can express this error. So A is equal to, generally if error is 10%, then we can say accuracy is 90%. If error is 50%, we can say accuracy as 50%. That means 100 minus the value is nothing but accuracy. 100 minus error value is nothing but accuracy. So in the normal value, we can say it as A is equal to 1 minus this percentage error. So A is equal to 1 minus yn minus xn by yn, where A is known as relative accuracy. A is known as relative accuracy. Another term is there, that is percentage error. So percentage error is nothing but just if you multiply this into 100, then it becomes percentage accuracy. So these are the four important parameters generally in examination. So these four parameters you are asked to find out. One is absolute error, and second one is percentage error. Third, accuracy, relative accuracy or accuracy, both are same. And fourth one is percentage accuracy. These are the four parameters you are asked to find out in the examinations for any problems in this error measurement. Let us see some example problems I have taken here. Here the values, what is the given problem? Let us see. The expected value of the voltage across a resistor is 80 volts. Voltage across the resistor is 80 volts. Expected value is given. What is the notation for the expected value? We have taken it as yn. Yn is equal to 80 volts. And coming to, however, the measurement gives a value of 79 volts. So that means after performing the experiment, we have got the value 79. That is, xn is equal to 79. So now you are asked to find out this absolute error, percentage error, relative accuracy, and percentage of accuracy. So already you know the first parameter E is equal to, what is the formula? This is Yn minus Xn. So difference is 1 volt. Simply the error, absolute error is nothing but 1 volt. And in the second question, percentage error. So percentage error, how to calculate percentage error? Percentage error is equal to absolute error by expected value. What is absolute error? Percentage error means into 100 is equal to 1 by 80 into 100. 1 by 80 into 100. So we can write it as this value will come 1.25%. If you simplify this, 1 by 80 is nothing but this value. And coming to third one, relative accuracy. Relative accuracy. So relative accuracy is equal to 1 minus E by Yn. 1 minus 1 by 80. That is equal to 80 minus, if you take LCM, 80 minus 1, 79. 79 by 80. That is equal to 79 by 80. That is equal to 0.98. 0.987 like that. And last question was percentage accuracy. So percentage accuracy is equal to just the value what we have got in the previous step into 100, that is equal to 98%. 98% is the accuracy. Hope you understand. So it is very simple. Generally these are the four parameters we need to find out in the case of a error in measurement: absolute error, percentage error, relative accuracy, and percentage of accuracy. So let us take another simple problem. In the previous case it is given in terms of voltage across a resistor, and in this problem it is given like current through the resistor. So current through the resistor, here also these are the four values we need to find out, like absolute error, and percentage error, relative accuracy, and percentage of accuracy. Here also four values we need to find out. So given Yn is equal to 20 milliamperes, Xn is equal to 18 milliamperes. So first one, E is equal to Yn minus Xn, that is equal to, what is the error? 2 milliamperes. In the previous case it was just voltage, now it is current. Whatever the parameter, whether it is voltage, current, or ohms, resistor value, anything, but the error is, it is the difference between what we are expecting and what we have got. Okay. And the second one is percentage error. So percentage error formula is equal to absolute error divided by expected value into 100. So absolute error is 2 milliamperes divided by 20 milliamperes into 100. So 2 milliamperes by 20 milliamperes into 100. So that is equal to 10%. Next, coming to third value, relative accuracy. So A is equal to 1 minus E by Yn. That means 1 minus E by Yn, that is equal to 2 by 20. 2 by 20, 2 milli by 20 milli, 1 by 10, 10 minus 1, 9 by 10, that is equal to 0.9. So last one, percentage accuracy. So percentage accuracy is equal to 0.9 into 100, 0.9 into 100, that is equal to 90%. So in this way we can calculate any of the unknown values like absolute error, percentage error, relative accuracy, and percentage of accuracy, if we know the expected and measured values. So coming to the next characteristics of instruments, those are dynamic characteristics. So in the previous lecture we have seen static characteristics, now dynamic characteristics. What a dynamic characteristics refer to? Dynamic is nothing but Dynamic is nothing but changing with respect to time. Changing with respect to time. Changing with respect to time. All the parameters what we are going to see in this dynamic characteristics, all those are varying with respect to time. That means every parameter deals with the time factor. So first one is speed of response. Again, in the case as in the case of static characteristics, here also we have list of characteristics, but here there are four dynamic characteristics available for the instruments. One is speed of response, second fidelity, third one lag, and fourth one is dynamic error. So first one, speed of response. Speed of response. What do you mean by speed of response of the instrument? When you switch on the instrument, I'm saying, giving an example, when you switch on the instrument, if instrument immediately responds and switched on and it is ready to use, then we definitely appreciate that type of instruments and always looking for such instruments. Suppose if the instrument is not responding immediately and after 5 minutes it is switched on, then definitely we will not go for such instruments. So here the time, how much time the instrument is responding with the input value, that is the speed of response. That means even whatever the input that we are applying, the instrument should respond immediately. The instrument should respond immediately, okay, without any delay. That is nothing but speed of response. Coming to fidelity, fidelity is nothing but faithful reproduction of input at the output. Faithful reproduction. Faithful reproduction without any loss. Faithful reproduction. Whatever the changes occurred at the input variable, the same changes should be occurred at the output. Same changes means for the same change, the corresponding output should be appeared. And the second and third one is lag. Lag is nothing but, we know the definition of lag is nothing but delay or retardation. Delay or retardation. So when you are performing an experiment without any delay, or even small delay is also allowed in the instruments. With such a small delay, the instrument should respond without any delay. That is what the lag meaning. Dynamic error. Dynamic error is nothing but dynamic error and static error both are same, but here in the case of static error, the values are not varying with respect to time, but here the values like measured value and expected value both are varying with respect to time. Both are varying with respect to time. Here also difference between the measured variable and expected value. But here the condition is when there is no static error. When there is no static error. That means when you are performing the experiment and when you are measuring the dynamic error, static error should be 0. Okay. So let us see the definitions one by one. Exact definitions. Speed of response. It is the rapidity with which an instrument responds to the changes in the measured quantity. Fidelity. It is the degree to which an instrument indicates the changes in the measured variable without dynamic error. That means faithful reproduction. Error is not there means 100% accuracy is there. Lag. It is the retardation or delay in the response of an instrument to changes in the measured variable. Dynamic error. It is the difference between the true value of the quantity changing with time and the value indicated by the instrument. Nothing but measured variable. Here also, see dynamic characteristics, static characteristics, error definition is same, but the values are varying with respect to time in this case. But in the previous case, in the static characteristics, the values are constant and do not vary with respect to time. Okay. So, but the last point is if no static error is measured, static error should not be there. Static error should not be there when you are considering the dynamic error. Okay. Thank you.